All right, so this is about the relationship between sine and cosine curves. And ultimately, in calculus, it's called derivatives. Here, we're talking about just slopes. The derivative is the slope of a function, but this will come in handy at various points throughout this course. So this is the basic shape of one cycle of a cosine curve. That the 2 pi there, notice that the graph goes out to a little bit past 6. This actually would be 2 pi. And because this is time right here, that 2 pi is the period of the graph, not the wavelength, but the period. If we looked at the slope of this graph, it looks like that. Now notice that looks a whole lot like the sine graph. I'm going to pop back to the previous graph. The slope, when you're doing something that's curved like this, you're doing the slope of a tangent line. So if you imagine that there's a line right there just barely skirting at this point at the very top, that slope is 0, and then at the very end it's 0. In the middle, the slope is 0. And then in between the beginning and the middle, we have a negative slope. And then from the middle to the end, we have a positive slope. And that's what's showing up over here. We have the negative slope in between, and we have the positive slope. That curve right there is actually the negative of the sine curve, which is displayed right there. So now if we change it slightly, we put a number right in front of the t right here. This is what the graph looks like. We're basically cramming in 2 curves where we used to have 1 curve. And notice again, we have a lot more zeros than we had before. We have a slope of 0 at the beginning, at the quarter mark, at the half mark, 3/4 mark, and at the end, and then negative, positive slope. But notice also, if we took that original graph and then we squeezed it, sort of crammed it in horizontally, we're actually making the slope bigger. So this is a negative slope as before, but it's also a larger negative slope. And so notice that the slope goes down to -2 and +2. And again, this looks like a negative sine curve, except it's got a bigger amplitude. And so it's -2 sine of 2t here. So that 2 that was inside next to the t for the cosine has mysteriously popped out front, and that is not just coincidence. Now, if we start out with a 2 in front of the cosine, this is an amplitude here. Instead of going from 1 to -1, we're going from 2 to -2, and it should still look like a sine of some sort. We start out with the slope is 0 in the beginning, the slope is 0 in the middle, the slope is 0 at the end. And in fact, it is a negative sine graph, as we saw before, but the amplitude is -2 to 2. And so the 2 out front just stays out front. So now we're going to add 1 inside here. Notice what happened is that our graph basically shifted. This +1 right here shifted the graph to the left 1. I'm going to jump quickly back to the very first slide. When we're adding 1 to it, in essence, we are starting here. When t was 0, we are now starting at this point right here and moving on until we get back to that starting point. So we shifted the graph to the left because we're starting ahead of where we were. And what's happened is we still have the slope here looks very much like the inverse sine or reciprocal of the sine as we had before. It's just shifted. And so all that's done is that +1 right there stays +1. This is known as a phase shift. That +1 is a phase shift, and the phase shift does not affect the slope at all. Now, if we tack on 1 to the outside like that, not adding 1 to the t, but adding 1 to the entire function, that has the effect of shifting the graph upwards. So instead of going from 1 to -1, we're now going from 2 to 0. The slope still looks like it did before. Notice that the slope is still centered around 0. But notice that the slope of this does not shift up. It's basically centered around 0 again. And so what we are left with is the major effects here. Slope of cosine gives us negative sine. And it turns out slope of sine will give us negative cosine. And slope of negative cosine will give us positive sine. And positive sine will give us a slope of cosine. And then we're basically back where we started. The 2 in front, if I have a number next to the t in front, this is known as the angular frequency in physics. that will have the effect of coming out front. And if we have an amplitude of 2 right here, that will just stay there. And those are the basics. So we have sort of summarizing slopes. If I have a cosine graph, the slope is negative sine. The slope of negative sine is negative cosine. The slope of negative cosine is sine, and the slope of sine is cosine. And when we get to here, we basically work our way back around. So if I have a position versus time graph that's described by a cosine graph, then the velocity versus time is a negative sine. My acceleration versus time is negative cosine. My jerk versus time is sine. Then my snap is cosine, my crackle, my pop, and so on. If I have a cosine of 3t versus t, what is my slope going to be? Well, the number that's multiplied by 3 here is basically taking my graph and then squishing it into a smaller space. And so that makes it steeper by a factor of 3. So we'd have cosine becomes negative sine, and then that 3 comes out front. If I have the sine of 3t, well, sine becomes cosine when I do the slope, and that 3 comes out, so that's 3 cosine of 3t. If I have amplitude out front and a number right here in the middle, well, that 2 right there automatically starts with a steeper slope. The 3 is going to make the slope steeper, and so we end up with, well, negative sine becomes negative cosine. And so I have negative 6 cosine of 3t because the 3 and the 2 multiplied together to get 6. So the slope of negative 6 cosine 3t, again, the 6 automatically makes the slope steeper, and then 3 is going to make the slope even steeper because you're squishing it into a smaller space. And so we have 18 because negative cosine becomes positive sine, or cosine becomes negative sine, and that negative cancels out with this right here. And so 6 times 3 is 18, so that's why you have 18 there. If we go into adding the full thing here, we have an amplitude of 2.5, we have an angular frequency of 3, we have a phase shift of 2, and then we have a vertical shift, for lack of a better term, of 9. Anyway, that shifts the graph up 9, but doesn't affect the slope. And so the slope is this 2 right here does not affect the overall slope. This 3 does, that 2.5 does. And so we end up with 7.5, because again, negative cosine times positive sine. 3 times 2.5 is 7.5, and then the 3t plus 2, and then the 9 has no effect.